All right, so we are asked to graph y equals 2x minus 3 and to identify its slope and y-intercept. Now, not too far from now, this is going to be a super simple thing to do. All right, it's going to be something that is so routine. You're like, oh man, this is the easiest question I've ever been asked. But what we're going to do is we're going to kind of pick it apart right now and learn how to do it. So it's going to seem a little tedious at first, but trust me, eventually these types of questions are going to be super easy. All right, this is what is known as a linear function, y equals 2x minus 3. It's linear because you've got x to the first power. All right. If it was x to the second power, we would classify it as quadratic. All right. It's a function because as you pick different values for x, you get different values back for y. We would say that y is a function of x, or we would say something like y depends on x. All right. Like x is your independent variable, y is your dependent variable. So in order to graph this thing, what I'm going to do is I'm going to do a little t-table. Okay, I'll do a t-table over here on the side. And the idea is that solutions to this equation are going to correspond to ordered pairs or points on an xy coordinate grid. All right, that's how we're going to get our graph. So solutions to this, there's going to be infinitely many of them. All right. Like if you say, oh, x is 5, that's going to give you 2 times 5 is 10. 10 minus 3 is 7. So 5 and 7, like together, make up a solution. Right? So a nice systematic way of coming up with solutions is to draw a little t-table, use label it x and y. And what I'm going to do is just go through and pick some values for x here. Some simple values. I'm going to use 0, 1, 2, 3, 4. I chose some values for x, and I'm going to get some values back for y. So 2 times 0 is 0. 0 minus 3, negative 3. 2 times 1 is 2. 2 minus 3, that's negative 1. 2 times 2 is 4. 4 minus 3, you get 1. And then 2 times 3 is 6. 6 minus 3 is 3. 2 times 4 is 8. 8 minus 3 is 5. All right, and you see here, these are all just kind of increasing by increments of 2. All right, negative 3 to negative 1 is just up by 2. 1 to 3, it's up by 2. 3 to 5, these just keep going up by 2. So if I wanted to, I could predict what 5 is going to be. It's just going to be up by 2. I could predict what 6 is going to be. Go up by 2. Right, and it's going to keep doing that forever. Right. So as x grows by 1, the y's are going up by 2. Now, each of these pairs represents a solution. So 0, negative 3 is a solution, and we call that an ordered pair. All right, this is how you would plot points back in pre-algebra probably. All right, or 1, negative 1 is a point that is a solution. Right? But these points, I'm going to plot them on a little XY coordinate grid. And once you connect all the dots, that's your graph. Okay. So 0, negative 3. Let me draw some little tick marks here. 1, 2, 3. 2, 3, 4, 5. Okay. All right, so let me start with something simple. 3, 3. So 3 over, 1, 2, 3. 1, 2, 3 up would be about right there. There's 3, comma 3. And then 2, comma 1 is an ordered pair. All right, this is my x, that's my y, that's my x-axis, that's my y-axis. So I'll go 2 on the x-axis and then 1 on the y-axis. All right. 0, negative 3 would be 0 to the left and right, and then down 3. And 1, negative 1. So 1 over down 1. All right, and you see here all the points, they form a nice straight line, right? That's what's unique, or that's what's nice about the solutions here. All of these solutions fall on this line, okay? Or you could say any of the points that are on this line correspond to a solution over here. That's the idea. All right, so we got our graph, the intercepts. All right, let me mention here a couple of little dudes. All right, this one right here, okay, where the line we drew, where it crosses the y-axis, that is the y-intercept. That is an important point. So the y-intercept is -3 here, okay? That's just the place where it crosses the y-axis. You also have an x-intercept. The x-intercept, even though they didn't ask us about it, the x-intercept is right there. It's just where it crosses the x-axis. It looks like it's halfway in between 1 and 2. It is 1.5 actually. The reason we know it's 1.5 is because if you plug in 1.5 for x, 2 times 1.5, you get 0 back. All right, that's like the defining characteristic for an x-intercept. It's the number that you can plug in so that you get 0 back. All right, but they weren't asking us about the y-intercept, the x-intercept, so we won't talk about it. Yeah. All right, what's the other thing? The slope. Yes. Okay. So the last thing here, it's the slope of this line. So the slope of the line is a fraction, okay? It's a ratio. Okay. The slope of the line is a number to describe how tilted this line is, okay? Right now, this line has, I don't know, a 45-degree angle, something like that. But it could be more tilted, right? This line, this pencil right here, if I moved it up a little bit like that, now it's more tilted. We would say that it has greater slope. Or it could be less tilted, right? Something like this. This pencil is less tilted than that line. Right? I would say that the pencil here has smaller slope. It has a smaller slope than that line. But the slope is a number that we assign to a line to describe how it's changing, or the rate at which it is changing. To figure out the slope, what you need to look for is, well, they call it the rise over the run. It's how the y values, or how the up and down is changing compared to how the left and right is changing, the x values. Earlier we were saying that as we went up by 2 on the y values, the x values were going up by 1. As we go up by 2, the x values are going up by 1. And that is the slope of this line. All right, the top number of my fraction is 2, and the bottom number is 1. All right, this is the slope of this line. You can tell what it is graphically if you kind of compare from points to points. It's how you have to move to get from one point on the line to the next. All right, notice from that point to that one, if I go up 2, all right, that's my rise, and then I go over 1, that's my run. All right, that's how you can figure out your slope. Again, if you go up 2, 1, 2, and then over 1, bam. Up 2, and then over 1, bam. All right. So the slope is just a way of describing how tilted a line is. All right. If you instead rose 4 and then went over 1, all right, that would be really tilted. All right, that's the idea. So the greater your slope is, the more tilted the line's going to end up looking. All right, I think that's about it. We've got our y-intercept, we've got our slope. We'll do some more examples. One of the connections that you do want to see here is you can figure out the slope and the y-intercept just by taking a look at this equation that we had originally. All right, you can figure out what the slope and the y-intercept are from that too. All right, if you notice that 2, that's our slope. All right, it's just 2 over 1. And then this number right here, that was our y-intercept. All right, we'll do some more examples in a little bit.